Hello teacher, hello students, welcome to today's lesson on the principle of development. In our last lesson, we have seen the placing of dimensions on views, dimensioning on limited space, and dimensioning of pictorial drawings. Let's briefly revise the previous lesson as usual. Dimensions should be placed in such a way as to enhance the communication of your design. Dimensions should also be selected carefully and placed on a view that shows the contour of the feature to which they apply. Dimensions should be placed outside the object for clarity. Moreover, dimensions should not be repeated on drawings. When the space between the extension lines is too small to permit placing of the dimension line and the dimension, an alternate method of placing them should be used. In dimensioning pictorial drawings, dimension line and extension line should be drawn parallel to the isometric axis. It's better to use a line system of dimensioning to dimension arcs and curves in pictorial drawing. In our today's lesson, we will discuss the use of surface development, the different types of surface and solid, the types of hem and joint used in sheet metal drawing, and the principle of development. But before we proceed to the first topic, let's discuss briefly the basic geometric elements. A point is a theoretical representation of location of an element or object in space. It has no dimension, that is, height, width, and depth. On a drawing, we can locate a point with a small dot or a small cross as shown in the figure. A line is one generated by a point moving away from fixed place. A line has location, direction, and length. A surface is two-dimensional geometric figure which may be generated by a motion of either straight or curved line. Any position of the generating line, known as generatrix, is an element of the surface. There are two types of surface, namely ruled surfaces and double curved surfaces. Ruled surfaces are surfaces generated by the notion of straight lines in certain desired path. These types of surfaces includes planes, single curved surfaces, and wrapped surfaces. Let's describe each of these surfaces. A plane is a ruled surface generated by moving a straight line along a line, lying in some plane in such a way that its new position of moved line is parallel to the original line. A plane surface may have three or more sides. A single curved surface is a curved ruled surface that can be developed or unrolled to coincide with the plane. A wrapped surface is curved ruled surface generated by a straight line moving so that no two of its consecutive positions shall be in the same plane. Helicoid and hyperboloid are some examples of a wrapped surface. The second type of surface is double curved surface. It's generated by a curved line and thus has no straight line elements. Sphere, torus, and ellipsoid are some examples of double curved surface. They are developable and non-developable surfaces. A developable surface is one which may be unfolded or unrolled so as to coincide with a plane. Surfaces composed of single curved surfaces or of planes of combination of these types are developable. Double curved surfaces are not developable. Wrapped surfaces and double curved surfaces are not developable. They may be developed approximately by dividing them into sections. Students, let's make things clear by doing some activities. A layout is given on the screen. First, fill each box with the correct term or terms individually, and then discuss in pairs how each of them is formed. Welcome back. Did you get it right? I'm sure you did. Let's do the activity together. Surfaces are divided into ruled and double curved surfaces. Ruled surfaces are surfaces generated by the motion of straight lines in certain desired path. Ruled surfaces are further divided into planes, single curved surfaces, and wrapped surfaces. Cylinder and cone are examples of single curved surfaces. Wrapped surfaces include helicoid and hyperboloid. Double curved surfaces are generated by a curved line and thus have no straight line elements. A sphere and torus are examples of double curved surfaces. Well, students, how are you doing so far? I hope you are doing great. Next, we will look at solids and type of solid. A solid is a three-dimensional representation of an object which may be generated by bounding plane surfaces or revolving of a plane figure about an axis. It shows height, width, and depth dimensions of the object. There are three groups of solid. The first group is called polyhedra. The word polyhedra is formed from two Greek words, that is, poly and hedra. Poly means many and hedra means faces. Polyhedra are solid figures in which each side is a flat surface as shown on the screen. The most common examples of polyhedra are prism and pyramid. Polyhedra are called regular if the faces are congruent, which is same size and shape. Regular polygons and the same number of faces meet at each vertex. There are just 5 regular polyhedra. There are tetrahedron, octahedron, icosahedrons, cube, and dodecahedron. Plane surfaces that bound polyhedra are called faces of the solids. Lines of intersection of faces are called edges of the solids. The second groups of solid are called solids of revolution. These solids are formed by revolving a plane figure about an axis in the plane of the figure. These include solids bound by a single curved line, such as cylinder and cone, and solids bound by a double curved line, like a sphere and torus. The third groups are solids that are bounded by surfaces. These solids do not have group name. The common example of such solids is screw thread. Well, students, do you know how real objects with the shape of a cube or cone can be constructed with a model paper? Next, we will answer this and similar questions. A development is the unfolded or unrolled flat or plane figure of a three-dimensional object. When surfaces of an object are laid out on a plane, the drawing obtained is called its development. The layout is full size and made on a single flat plane. Making surface development is an important part of industrial drafting. Many different industries use surface developments. Familiar items such as pipes, parts of buildings, aircraft, automobiles, cabinets, office furniture, boxes, and cartoons are designed using surface development. To make any such item, a surface development is first drawn as a pattern. This pattern is then cut from flat sheets of material that can be folded, rolled, or otherwise formed into the required shape. Paper, cardboards, plastics, wood, fiberboard, fabric, and metals such as steel, tin, copper, brass, aluminium are some of the materials used for surface development. Well, how are you doing so far? I hope you are doing great. Now, let's do some activities to check how much you've understood the lesson. An object is given on the screen. Draw the pattern of this object. Use your time properly. Welcome back. Did you draw the pattern of the object correctly? Wonderful. The solution to the activity is given on the screen. Students, there are general rules that a drafter should observe during the development of surfaces. Next, we will discuss these rules in some details. Development of solids are usually made with the inside surfaces up to facilitate bending or rolling during manufacturing. It's possible to begin development of solid from any age. However, it's good practice to start and end with the shortest age. This helps to use fixing materials such as glue, soldering, welding, and riveting economically and give strength to the final product. When making the development of a solid, elements should be labeled using numbers or alphabets in the clockwise direction. Bends or fold lines should be clearly shown in the development so that they will be used as guides for rolling or bending the final product. Extra material used as lap or seam should be provided at the end element lines of the development where fixing or fastening is required. The amount of materials to be added varies depending upon the thickness of the material, the type of connection, and production equipment. Well, how are you doing so far? I hope you are doing great. Next, we will look at hems and joints. Students, do you know the function of hems and joints? Let's see. Hems and joints are materials used during the manufacturing of ducts, tanks, containers, and other products made from sheet metal. Hems and joints are used to make the edge of material smooth. They are also helpful in making the material strong. Various types of hems and joints are used during the manufacturing of materials. Some of the most common type of hems and joints are shown on the screen. Students, let's do some activities to check how much you've understood the lesson you have just learned so far. The patterns of an object are given on the screen. The patterns have mistakes. Identify the mistakes and then draw the patterns correctly. Welcome back. Did you complete the exercise? Excellent. The solution to the activity is given on your screen. Well, students, I hope you've gained a lot of concepts from today's lesson. Before we come to the end of this program, let's summarize the main points. A surface is a two-dimensional geometric figure which may be generated by a motion of either a straight or curved line. There are two types of surface, namely ruled surfaces and double curved surfaces. When surfaces of an object are laid out on a plane, the drawing obtained is called its development. To make different items, a surface development is first drawn as a pattern. A drafter should follow certain general rules during the development of surfaces. Well, students, that brings us to the end of our lesson for today. Keep on practicing on the methods of dimensioning. In our next lesson, we will learn about the principle of development. Until then, thank you, teacher, and thank you, students. Goodbye.